Hello, everyone. Welcome to the Pursuit of Mathematics. In the seventh episode of our series, Math and Education, we have a very special guest, Mr. Andrew Tinglev. Welcome, Mr. Tinglev. How are you?
Good. How are you?
I'm all right. I'm still now struggling about this, broadcasting things.
Yeah,
But
aren't we all?
no. So I think we are in the midst of this, coronavirus pandemic. So as teachers, we are forced to pivot our instructions online to allow teaching and learning to continue. In your opinion, what are the challenges of teaching remotely?
Yeah, I think the biggest challenge for me is communication. I don't feel like I have the normal communication with my students. I can't really tell how they're reacting a lot of the times. So I think that's kind of the biggest problem. And they're much quieter. When you have a Zoom session, the students are much quieter. So
Mhm.
I think the communication thing is difficult. Um, I think it's going to be even more difficult if we don't meet them face to face. So, like, for example, here I had a relationship already with my students, right, face to face through at least half the year. And then we went on to Zoom, right?
Yeah.
So I don't know what's going to happen if we don't start face to face, and you have to start that relationship with your students, immediately on, a digital platform. So,
Hmm. By the way, I forgot to ask you. Could you introduce yourself for our audience? Well,
okay,
I'm so
sure.
excited. So sorry for that.
Yeah, my name is Andrew Tinglev,
Uh-huh.
and I'm a math teacher at Robert College, and I've taught here for 20 years. My wife also teaches here. She's a biology teacher, and you might have seen her at like ATC or presentations as well. Sometimes we present together, actually,
Mhm.
on biology and math. We do combine our subjects sometimes, so that's kind of interesting.
Mhm.
Um, and right now I'm teaching, I guess it's been like maybe 8 or 9 years. I've been teaching AP statistics.
Mhm.
And last 3 years I've been teaching discrete math. But in the past I've taught pretty much everything like, calculus, AB, BC,
Mhm.
all of those, AP courses, plus, the normal kind of core courses that you would teach in math. So
Mhm.
yeah, and should I
So
mention the clubs? I have two clubs that I'm involved in at school. One is the Adventure Club, so it's an outdoor adventure club, and I'm also involved with the Sailing Club at our school. So
yeah,
that's a
like
little
you
bit about,
said, you're teaching AP statistics. What
yeah.
is AP actually? Could you just give some
So
information
AP
about it?
stands for Advanced Placement,
Mhm.
and it's a U.S. program. And the idea is that it's supposed to be a class that's equivalent to a university level. It's a year-long course, and so it's a year-long course in high school, but it would be equivalent to maybe a semester-long course in university. And in students in the States, if they at the end of the year they can take an exam. There's an AP exam, and depending on the university that they're applying to, and if their grade is high enough, like 5 is the highest grade you can get. Some schools accept 4 or 5, some accept only 5. It really depends on the university. But they may say, okay, you've tested out of this course. You don't have to take AP. You don't have to take the intros to this course in university, for example.
Mhm.
And then other schools like in the UK and stuff, when students are applying, they also like to see AP sometimes. Sometimes UK universities will give like a conditional acceptance and say, you need to score a 5 on the AP and then we'll let you into our university. So there's actually different ways that AP are used, but the idea is essentially that it's supposed to be equivalent to a first year course in a subject in university. So
Oh, okay. So, like, if they get a calculus course from the
yeah.
AP, when they
Hmm.
go to university, they don't need to take another calculus course, right?
Yeah, that's a little more confusing because calculus has two courses, A, B, and
Mhm.
BC. So if you think about it, the B kind of overlaps right between them.
Mhm.
So it depends on the university. Would the AB is the lower one and the BC is the higher one. So the BC they get about maybe a third more material than they would in the AB. Mostly stuff with series like Taylor series and things like that are covered in the BC, which aren't covered in the AB. So it's really dependent on the university whether what level do they want to accept the AP at. So I always tell students, talk to your university and see, because most of my, when I teach them, they're seniors, so they've been accepted halfway through the year. Ask the university what level, do you want that AP to be at? Because they usually take the AP exams in the spring. So.
So today, like you are teaching currently statistics and discrete math and lycée prep math, right?
And also lycée prep math, yeah. And I've been doing that for a couple of years now.
So I would like to learn about your experiences about teaching these topics remotely. How do you do that?
Yeah, sure.
It sounds so complicated. It sounds so unreal, by the way, for me. Statistics itself is so difficult for us, especially for for the ones who are teaching Turkish curriculum. It's so hard to teach because we're not used to teach statistics.
Yeah, I think it's hard for any math teacher. I don't think it matters where you come from, because still in most of our training, we don't get much statistics. Like I remember when I was in university, I only got a semester of statistics, for example. And I didn't remember any of it actually until when they started teaching AP stats. And I think the other issue is that the style is so different than what we're used to in other math classrooms, because there's more of a language component to it as well, especially for AP statistics. You have to describe what you're doing. There's calculation, but there's also you have to describe what you did and describe your conclusion and describe your hypotheses and things like that. So there's more language than most math teachers are used to dealing with.
Yeah, exactly. So how do you teach statistics? Let's start from this.
Okay. So a typical class for me is to introduce the topic, usually with some sort of graphic. And I'll show you that when I get to the presentation part, but something for them to discuss first of all, and usually informally, right? So they can get most of the ideas, or ask them what they think about it, right? Like here's a graph of something that's happening during COVID-19 or something like that, right? And where do you think this graph is going to go, or things like that, or what do you think the trend is, or what do you think about the data source, or there's all sorts of questions that you can ask that leads you into it, and then usually I get into the details after that, and start using some of the language. But usually I want to hear from the students first before I say anything, because I want their ideas. They can use whatever language they want, right, in the beginning at least, right?
Yeah.
And so that's usually how I start a class. And then as we talked about earlier, I use Pearson, Pearson mastering system. So those of you who are not familiar with it, Pearson's a textbook company, and they have basically online, it's an online textbook with a hard copy option, but it has multiple choice questions that they can try. And in statistics, it also has another component, which is it has a statistical program called StatCrunch. So any of the multiple choice questions that they try, if it has data, like, you don't want your students doing data entry, right? That's a complete waste of time.
Yeah.
So the data from the question directly goes into StatCrunch. You can do whatever statistical thing you need to do, and you can bring it back to the multiple choice or fill in the blank question that you were working on, which is good for a starting point, I would say. That's kind of just a quick check and to see where are they at, right? Are they understanding it, and they get immediate feedback. But to me, that's only just a starting point, because it doesn't help them with the language that much. They actually have to express themselves and describe what's happening in the statistical process. So the next step usually, so my first lesson, an introduction, maybe they'll do some mastering. And then my follow-up lesson, usually in an AP stats class, is to be on Google Classroom. And the students will do some, longer free response questions where they have to respond to, in like a paragraph kind of format.
Do you prepare these Google Forms?
Yeah, actually, that's also coming from their textbook, the response questions. But yeah, I do prepare a Google form that's like a template. So that on that template, I tell them which questions they're going to do from the Google form. I mean, sorry, that's not a Google form. From the textbook, which questions they'll do. And then usually during usually we start in class, and I have, I'll have it up in Google Classroom, and I'll just go through student after student as they're working, right? And correct any language issues that we have or anything like that. And then after the class, usually what I do is, go back and look in a more detailed way, because sometimes, you get interrupted in a class or things like that. But so they actually get feedback twice on those kind of questions. I usually get to everybody in the class normally, and, they at least get a quick feedback in the class, and then they'll get a more detailed, feedback later. So it's kind of intensive, right? Like time intensive to do that, but it's, an important part of I think, having them express statistical knowledge, right? Use the right terminology. So it's kind of a critical part. Yeah.
It's important for the student engagement as well. So
yeah,
in some way they can be more active, I think, and they can participate in the classroom.
Right.
In this way, I think. And you can do some kind of formative assessment as well in order to check their prior knowledge, maybe.
Yes. Yeah. It is kind of a formative assessment in a way. Yeah. I would definitely agree with that.
So what changed when you have this, coronavirus, after coronavirus? How did you change your classroom settings?
Well, luckily, actually more change in the lycée prep class than change in the statistics and discrete.
Oh, really?
So, yeah. Because these classes were already using online textbooks and, online resources. So the biggest change, I think, is kind of when you present material and try to, have a class discussion. That was maybe the hardest part. So there were some activities. Should I go to my presentation maybe?
Yeah, why not?
It's kind of an informal presentation, but I just kind of pulled together some stuff that I had. So let me share my screen, if you don't mind.
Yeah.
Okay, let me start this as a presentation. Okay, so like I said, this was kind of just an informal presentation. I didn't make it too fancy or anything like that. But let me start with lycée prep a little bit, and talking about what changed with that, right? So the lycée prep was actually more of a traditional class than the other ones, and so at the time we were just working on linear equations. So as everybody was, we were kind of in crisis, right? Because none of us are used to working this way. So so basically what we did was we created a Google form, and the topic here was linear equations. It should open up from here.
Okay.
Yeah, so you can see that. Okay, so this was actually a group of us just, early days in the I think it was in March at some point. We wanted them to do kind of a check or whatever. So they just had to find an equation of a line, for example, and they would add a file. This is in a Google form. They would upload their picture essentially. So a lot of teachers were working this way. I've done a lot of Matematica programming, and actually the presentation that I'm using here, I almost always gather my thoughts in Matematica. So I wanted to enhance actually what they did. So if you see, there's a little bit link here. So this is kind of my first attempts to use Matematica in the cloud. So I wanted the students to have a little bit more of an interactive thing. So I created these little cloud things for them to try. So it looks like this. And the students would have to come in. I'm going to enter a wrong answer to start off, maybe.
All right.
Okay, so it's going to come in here, and they just submit, and it prints out a graph, and where the point was. I think, what did it say? Slope, intercept. Yeah. So basically it shows them that the answer is incorrect on this, right?
Yeah.
Okay, it's not going through that x-intercept point, and it would just say true if they did it correctly. Okay, so this is kind of my just first attempt, and I added it onto this work that the group had done before. So I wasn't quite sure if this is the way to work. I can show you what I did actually a little bit. So that question you just saw, I actually coded that out. So this is the code in Matematica. And I wasn't too familiar working with the cloud stuff. So, there's a lot of stuff here, obviously. But here it says form 1, right? So form 1, basically I'm running this locally now on my computer. So if I do this, it's going to show you, what that form would look like on my computer. And the important thing is I can deploy that to the cloud. So if you see here, it says cloud deploy. Okay, and when I do that, it creates a little web page where I can do something, interactive. Okay, so we're going to see a lot of that tonight because that's where I started off. I always go back to Mathematica because that's kind of what I know. It's not always the easiest option, though, I'll have to say. And sometimes I was crying, so. But I like to use it, and I like to do my presentations in it too, because when I'm working with students in a statistics class, discrete class, doesn't matter what class, like this presentation, it knows math, so I can just directly, ask what is 2 + 2 = 4, things like that. It can also, if you're in a Mathematica document, pull up, Wolfram Alpha searches. So I can just go like this, because sometimes kids ask me, so what year was Leibniz around, for example, and, I can just do a quick Wolfram Alpha search. I thought it would be quick. My internet's slow. Yeah, and it pulls up all the details that you would find on a Wolfram Alpha page, except it's in the notebook, right? So I don't have to jump somewhere else. I can just do things directly in the notebook. So
it's a great thing to use. Wow. How long have you been using Mathematica?
A long time.
Long time?
All right. Yeah. So yeah, about 15 years.
Okay.
But I have to say, starting up with it is not easy. So it definitely was worth it for me, because I use it all the time. But you have to use it all the time to learn how to use it. But
as far as I know, they published an ebook in the Wolfram Alpha about Mathematica and learning the language.
Yeah, they did actually, and that's quite good, right? There's a I think it's called Intro to Mathematic or something like that.
Yeah,
is that the one that Stephen Wolfram? Yeah. Published? Yeah. It's quite good. But I warn you, it's not the easiest way to start. But the thing is, you can do anything. So when I go into topics like discrete math and stuff like that, you're not going to find much in Desmos, for example, on discrete math. And Mathematica can do all the graphs and all the visuals and things like that. And it does, some things that I wouldn't be able to do anywhere else. So that's the advantage for me. But the disadvantage is that you kind of have to learn the language. So right now I'm just using it as a calculator, so that's easy. But if I want to make a nice, interface or something like that, you might have to work at it. You can make simple interfaces, there's this great command, it's called manipulate. Actually, maybe you know it, I don't know.
No.
I don't know what we want to do. Maybe I'll make a plot or something like that. So basically I just have a plot here. It's gonna plot hopefully a line that goes from 0 to 10. This should be multiplying this. And basically what it's going to do is just programmatically create an interface just with a line on it. I hope I did everything correctly there. Let me just see. Yeah, there it is.
Wow.
Yeah, so that's, a pretty fast way to an interface. I need to maybe work on the axes a little bit. So it's actually just readjusting the axes. So I could add, extra things on it, make it, nicer. But sometimes I even use that in class. Like there's something that a kid wants to see demonstrated. And if it's easy enough for me to do it, I do it simultaneously in class. But if it's too complicated, you need time outside to do that. So
yeah.
So that's just kind of a little aside that, I always use Mathematica to do things like that. So.
It's a great thing to, use Wolfram Alpha at the same time as well.
Yeah, that's really nice sometimes.
Yeah.
You just want to do a quick Wolfram Alpha search. I don't want to jump to, Chrome or whatever. So yeah, I just do it directly from there. Okay, so that was kind of my first experiments in Lycée Prep Math. So here's another manipulate function. Looks a little more complicated. So this is again for Lycée Preps, and we were talking about functions, okay? So what I'm gonna do is I'm going to execute this, okay? So this is what, basically just a simple function machine. So I would ask the students, it has an input, it has an output, and they're kind of learning the language because they're Lycée Preps. And what's the rule, right? So you ask them, what's the rule, and you can tell them like, okay, maybe we can put in different inputs. There's something like this on Desmos now, I realize too.
Yeah, yeah.
I programmed this years ago, actually, but I don't think it was on Desmos years ago. But yeah, and so my version, the teacher version, actually shows you the rule, but I think the student version didn't.
Yeah.
If I remember correctly. So, you know, and you can just try different functions. There's like a square root function, for example, and things like that. So, you know, that's another example of a manipulative. Now, what changed is, you know, normally I would do this in the classroom and this would be displayed. And, you know, so, but I still want the students to try this. So again, I cloud deployed this. So this went to the cloud. So I, again, created a Wolfram cloud object. Hopefully it'll come up. You'll see the cloud version. The cloud version is a little bit slower than, you know, the other ones, but it still works. So it would still do all the inputs and stuff like that. The reaction time is just a little bit slower. So, you know, I would send that out to the students and the students would, you know, try that and try to come up with the function. And we would do that, you know, talking through Zoom basically. So. So that just gives you another example of, you know, a cloud deployed object. Okay, let me continue. So I'm actually going to, this could cause me a problem, and it might have already caused me a problem. Let me see. Yeah, because if I have too many interactive things, it could really slow my computer down. So I'm just gonna cut that piece out, the interactive part, and hopefully we won't have any problems or reset. Yeah, another one that we did was we were talking about geometry. And so I also cloud deployed this one. So as you can see, like the coding's not that easy, but a lot of it is just drawing stuff. So you
This
would
is
have
about geometry, I think, huh?
Yeah, so it's about like, you know, perpendicular bisectors, medians, altitudes, you know, we're trying to get them used to those terms. Maybe I can make it a little bit larger. It only makes this part larger. Anyways, yeah, and it draws, you know, like it'll draw the median. It'll, you know, draw the altitudes. You can mark the orthocenter. You can mark a centroid, perpendicular bisectors, and you can put the Euler line in if you want. And you can also, the other nice thing is you can tooltip these. So like I actually tooltip them as well. So, you know, the kids could actually see, okay, if they're checking their answers, what is the equation of that line, right? So everything's tool tippable. I don't know if that's a real word, but I just made that word up on your broadcast. Okay, so that's just another word. Yeah. So that's just another example of something that, you know, was cloud deployed. But like I said, that's a hard way to go.
Yeah.
And actually at some point I was getting tired. So I did get back to, I think the next one's about Desmos, yeah. So, you know, at some point I started going back to Desmos, which is a program I have used, but, you know, I think like you said, I was using it maybe mostly as a graphing calculator. I did some of the card sort activities. So this is definitely you know, a site I would recommend for teachers to try out because you can do it at just so many different levels. So the first thing to do is, to start with, you know, just an activity that someone else has already built. And so these are available at teacher.desmos.com. So I'm going to show one that we used during the distance learning, and I think it was absolute value. Let me see here. So the dashboard's coming up, yeah. Yeah,
I like this interface, by the way. So you can, you know, observe all the, you know, student work here, and which student is which question, who is struggling or not. You can easily observe it.
Yeah, so maybe let's talk about the dashboard first, because it is really nice. Like, you know, because one of the problems I had was, you know, kids are moving at different paces during a lesson, you know, which you would kind of be aware of what's going on in the classroom, but it's a little bit harder to be aware when you're doing distance learning. So it has very nice features. One is that you can, basically each one of these that you see that I'm up here is a slide. Maybe I can show that a little bit better. Let me go back. Let's see, where was I? Let me just show the summary again. Yeah, so each one of these is a slide, but you can restrict which slides the students work on. So there's a pacing guide. And so the pacing, you can say, okay, I only want the students to do the first 2 slides, for example, right? and then it'll stop them from going to the next slide. So, you know, we can kind of move together, which is very helpful when you're doing synchronous learning, you know, because you don't want kids all over the place. So that's a nice feature that you can use. So let's say it's restrict to those screens, and you can see where all the kids, what they've completed so far. So that's also nice. The other thing I liked is, you know, you can, and I probably should have done this, anonymize, which basically means don't show the real names. Yeah. So they, you know, they come up with all these mathematicians like Galileo is on
but
here.
After clicking this button, how do you understand that which student is who?
Yeah, I don't, but I don't necessarily need to. You know, they know who they are sometimes. You know, I think they know, right? As far as I know, I think they know, right?
Yeah, they know. Yeah.
Which student they are. So, you know, yeah. So on the next activity, actually, I use the anonymize a lot, and I just wanted them to describe an absolute value in English. So this is this activity. I can just show you if we click on a student slide here. They were just, you know, using a number line to show where the absolute value points would lie, basically. But let me show you the one I built. So that my next stage was, this is just one that was created on Desmos that I used. And then the next one that I went to was one I built myself. It was very simple, the one I built myself. But it was easier than, you know, setting it up in a Matematica. And, you know, I don't have the dashboard in Matematica, and, you know, I'm not going to build the dashboard because that would drive me insane, pretty much. Yeah, so here's one that, you know, I said, okay, let's translate the sentence below into an absolute value inequality, you know, kind of just a basic thing you would do with preps who are trying to learn English. The real numbers are a distance of at least 5 from 2. So I can see all their equations. Some use set builder notation, you know, some used absolute value, some didn't use absolute value. And you can just kind of go through and comment on, you know, what the students did, right? You don't even have to use their names. You could use their names if you wanted to. And it also has an option that you could even make snapshots, right, of certain screens of the students. So maybe there's something a student did that you want to show everybody. You know, you can also add that. So yeah, I definitely recommend. There's so much you can do on this Desmos site that I was really impressed with. Let me show one of the slides where they had to use some English, maybe. Yeah. So here they're trying to describe the absolute value of x is less than or equal to 7, and all their different responses, right, that they had to this. So that was really helpful for me to talk them through the English of that, you know, and see which ones were more correct, less correct.
Especially for the prep students, it's so important to, you know, translate a mathematical statement into English.
Yes, exactly. Yeah. And I want to see what they're doing, right? You know, and so when I was running a synchronous class, this really worked well for me, actually, was to just, you know, see what everybody's doing, be able to comment together in Zoom, you know, I think, you know, was definitely something worthwhile. For the future, I started looking at, you know, if this is something, if you really get into Desmos, and I'm not fully familiar, I have to say, with there's something called the computation layer, which allows you to do sort of programming, but it's not really programming. It's really a scripting language. So I'll open that. If you just type, you know, Google computation layer, it'll come up, the documentation center. So hopefully it'll load here. It's a little bit slow loading. So basically the computation layer takes it even a step further. So you have the activity builder, which you could just build an activity and you could build different components. The computation layer allows you to make even more sophisticated Desmos things by connecting those components together. So the idea of the computation layer is that it will connect the components together. And so students, for example, in a statistics class, or if you're doing some data stuff, right, there's functions like aggregate, where the students could enter their data and then Desmos will aggregate it and show everybody in the class, like, you know, what the result of all that data was, for example, or, you know, the whole set of data. So, you know, that's something else that you could explore. and I'm just starting to explore, so I can't really say that I'm, an expert on it. But I think those are the steps that if you want to do Desmos, first try one of their own, then maybe try to edit somebody's, and then maybe try to build your own using the activity builder, which would, just put the components on there. And then you could take that even one step further, which is just to, go on and create your own that, some pretty sophisticated things. So that's just my 2 cents on Desmos. I'm nowhere near being an expert, so. But it's definitely a place to look. So.
Yeah.
Okay.
And it's getting more and more popular, but with Desmos, and like they're uploading a lot of activities in there.
Yeah, they have an interesting story too. I don't know if you know about basically it was set up, I think, in 2011 by a physics student at Yale, and this physics student was tutoring in Connecticut. Yale's in Connecticut, in 2 different communities. So Yale's in New Haven, Connecticut, and New Haven's kind of a poor area. And he was tutoring students there who couldn't afford to buy a calculator, right? And so one of the barriers for these, low-income students was actually the TI, right? The TI graphing calculator, and the fact that it cost, whatever, $100+. And then he was also tutoring in Westport, which is a wealthier community, and it was no problem for them, And so he was kind of frustrated that the calculator was the barrier for some of these lower income students. So he created a company called Desmos, and it's based in San Francisco. And the idea was that he changed the business model. So the business model was that TI would charge, the schools and the students, right? And the publishers would be able to use TI stuff for free. Whereas Desmos is the opposite of that. So Desmos said, if you want to use our tools, or you want to use snapshots of our calculator in your textbooks, they charge the publishers, and for teachers and students it's free. So it's the exact opposite model.
It's exact opposite. It's so great to having such an app like this for students.
Yeah, so it's kind of interesting, actually. Yeah. So that's a whole nother story, TI's monopoly on graphing calculators. So we won't get into that, but that's kind of the story of Desmos, and it's kind of interesting. All right. Okay. So maybe I should talk a little bit. Oops. Is this where I wanted to be? I don't know. Okay. Yeah. We'll talk a little bit about statistics. So so my statistics class, actually my students said my statistics class didn't run that much differently in distance learning.
Oh, really?
But it does, I don't completely agree with that. Maybe in general, when you're doing the mastering and you're doing the Google Classroom, all that can be followed. Also, we had less students showing up. That was, another reality as well, Normally I would have 24 students in an AP stats class. Since they were seniors, they started dropping off. But I tried to also do some activities with them. And I think, some of these activities that we did, you can do at different levels. It doesn't necessarily have to be an AP stats course. So one thing we were looking at is, a pair of dice, right? And do you think your dice are, do you think your dice are fair, right? And how might we figure that out, right? Well, we don't know 100% ever really if your dice are fair. So actually, I have some manipulatives. So. I also did the activities with the students, but I don't know if you guys can see this, but I used one of these die instead. And you can see like the sides are a little bit different. I have 2 of them actually. They're skewed. They're skewed though. The faces are not squares.
Oh.
If you can, I don't know if you can see that.
The screen is so small, so like I
maybe it's. So they're basically skewed dice, right? Okay. So all the sides are. I don't know what figure would that be, like a not a parallelogram. I don't know. They're weird. Basically, they're weird.
Okay.
So they don't look like normal dice. So I did the same thing, right? But they're still fair. That's the interesting thing, right? So these
Oh,
dice are
okay.
still
This
fair,
is surprising.
despite
How,
their weird,
how can they be still fair?
skewed shape, right?
Uh-huh.
So I tested this out. So the students did it with normal dice. So I figured most of them had dice at home, right? So this is I just did a Google sheet. They did, die one. How often did I get a one? How often did I get a two? Die two. We also looked at the sums as well. So this is something you could do, probably at any level. It's the analysis part that might be a little bit different, right?
Uh-huh.
Like, so in an AP stats course, we have, more sophisticated ways of analyzing this. But, students will ask questions like, well, I got a run of sixes. Is that, mean my dice is not fair, right? So it's kind of a place you start, and most kids, have dice at home. So, so we did it with AP stats. So ours was a little more sophisticated. We used chi-square actually to look at this. So we started with that, and there's lots of things that you can, lots of discussions you can have. I think also an important discussion whenever I do probability is to talk about randomness.
Yeah.
Because kids have this, they don't really understand random actually, right? So, what it means. And I think actually whenever you teach probability or you're rolling dice and things like that, it's probably important to go back a step and actually talk about randomness, because people don't really understand it very well, and actually what I usually have the kids do, I have a website where they try to fake a set of heads and tail flips, right? So they have to do, they just go on the keyboard, HT, 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 HT. And then we do some statistical tests to see like, what are the chances of that being, random, right? And so they think that, if I just act strange or erratically, right, that's random. But humans are really bad at acting randomly. So the kids realize that they fail, right? Like most of the kids will fail, like trying to fake heads and tails, randomly, right? And then they realize, well, this is like harder than I thought, right? So
the most frequent question that I get in the probability topic, that is, students ask me this question, like, okay, the probability of getting one, if you roll a dice, if probability of getting one is 1/6, right?
Yeah.
But like, let's say I roll a die, like, how can I say, like 60 times, but like I got one, not 10 times, but like 15 times. So how can you explain this phenomena?
Right, true.
Oh,
there's also some interesting experiments I was reading about like, is heads and tails really random, right? Yep. And so they've had, I guess, some laboratory tests where they have like a robot, and they try to control all the conditions and things like that. And they said, it's not really random, it's actually deterministic. There's just so many things that determine whether that turns out to be heads or tails in the end, so that's another interesting discussion that you can have. So we did that, and then we took it one more step, which is to talk about, I don't know if you're familiar with the game rock, paper, scissors. Yeah, it's kind of a standard one. So we also did this with chi-squared as well, but we did something a little bit different. So the students, use Zoom, and we use the breakout rooms. Do you know the breakout rooms?
Yeah, I know. And
they played rock, paper, scissors against each other.
Okay.
And then I had this link for them where they play it against a pseudo-random, basically just a pseudo-random generator on the internet that's going to produce, rock, paper, scissors.
Okay.
And see how that comes out. And then the next thing that they did was they did it versus, there's also, I found an AI version, right? So the AI version tries to look at the patterns that you're, doing when you do rock, paper, scissors, right?
Wow. So it can like look at the pattern that you're using? Yeah. And then like create a strategy.
So I was trying to discover like, because we said before, humans don't really act randomly, right? It's trying to use AI basically and try to figure out. So there was another one that we had, and I used this site basically to try that. And I wanted them to like compare like statistically all three techniques, right? And, is the AI really doing something, Probably we didn't have enough data to make a conclusion, but it's kind of an interesting discussion to have, right? You know?
Exactly.
And it's something that we could do online, right? So all this stuff they could do online, and it's an interactive activity. So
in
yeah,
this way, they can engage to the topic. Wow, well,
yeah.
I like this website.
Yeah. So that was kind of interesting and something new I tried, you know, and this is not a, you know, a normal activity that we would have in the classroom. So yeah, that kind of worked out well. Okay, so I'm still talking about statistics, and maybe then after that I should talk a little bit about discrete, because I haven't given discrete very much time. So this one is about basically linear regression. It's actually about linear regression inference, so it's a pretty late topic actually in the AP statistics. So AP statistics, basically it's a range. So the first semester we do just descriptive statistics. So you're just describing different ways of describing data sets. The second semester it's inferential. So we try to talk about, you know, from a sample, we want to say something about the population. Okay, so more abstract, a little bit more difficult. So this just gives you an example maybe of like a presentation that I would do, but I updated this for the distance learning because I wasn't in a classroom and I wanted to display things a little bit better. So this was also written in Matematica. I'm going to open this up. Hopefully it will open up. Yeah.
Wow.
Yeah, so this is just kind of, like I said before, I like to introduce things beginning with pictures, you know, start with the pictures first. Although at this point, my students know quite a bit about linear regression, I would say. Let me actually go to the next interactive one. So, oops, I need to enable the dynamics. I did release this as a cloud version for the students as well to use. So basically what it's doing is it's looking at the amount of fire damage. So we're in a hypothetical town. It's not real data, unfortunately. We are looking at the amount of fire damage versus the distance from the fire station, right? And we want to, you know, try to come up with a linear regression from that. The reason it's inferential is because we only have a sample, right? So we want to take the sample and we want to infer something about the population, right? So I created this one where we have a sample size of 10. Okay, so right now we can't see the sample, but if I click on this one, I said highlight the sample points. Okay, so it randomly highlighted some sample points from the population. So the ones you see in blue are, you know, let's say my entire population of data. Okay, and I wanted to show a sample line. So that's the linear regression for the sample line. And then, but the sample line is going to try to predict or try to, you know, guesstimate or give me an idea of what the population line is, right?
Yeah.
So the population line is the one in blue. Okay, so I usually start with this diagram to get them thinking about it. And, you know, what happens if I change the sample size? Well, if the sample size was 5 or something like that, you know, there might be a bigger difference, maybe not, right? And actually I can go through different samples too. So each one, every time I click on this plus button, it's going to give me a different sample. So, you know, we would have discussions about sample size and, you know, how well is an estimate I'm going to be coming up with. There were a lot of other things because, like I said, the kids at this point are pretty advanced. So we look at the histogram of the slopes. We look at the population statistics. This is a residual plot for the population. This is a residual plot for the samples. You know, not everybody might understand that, but I think the important thing is, again, that we just start with a visual and, you know, we work from there. But I really updated this for the distance learning. And, you know, I think it generated good discussion as well.
Yeah.
Okay, maybe I should shut this one down though, because I'm just worried my computer's not going to be handling all this, which, you know, because I don't usually run as many interactive things as we do during the presentation. You know, usually it's one thing. Okay, so let me talk about discrete math, which is a little bit different because I'm not really constrained by a curriculum. I have maybe the math teacher luxury of doing whatever I want, pretty much.
Like, could you just, you know, I don't understand. Like, how do you not, following your curriculum? Like, what kind of luxury is that?
So
I don't
discrete
understand.
math is an elective course.
Uh-huh.
And for those of you who are familiar with discrete math, I think the easiest way to describe it is it's anything that's countable usually counts as discrete math. So if you can count it, it counts as discrete math. That's how I have to, because my students have no idea. They're like, I get the students coming for electives like, what is this discrete math? And its closest connection is usually to computer science. So we get a lot of computer science students. And so, but it doesn't necessarily have to be computer science. It's also involved in like things like scheduling and logistics. And, there's a lot of areas. Hopefully I'll have time to show a few examples from politics actually as well.
Wow.
So from the political spectrum, fair division and things like that. There's a ton of things that, fall into discrete.
Do you start from the counting principles and then like combination, permutation or something?
Yeah, that's in there as well. Yeah.
Right.
Yeah. I mean, because again, you're counting, right? Like
yeah.
If you can count it, it's discrete. Yeah. So yeah, it's almost like not another branch. It combines lots of things from different branches of of math. It's so large. So by the time we got to we do just a quick overview of the topics that we do. We do graph theory. We do logic. We talk about computational theory, like what is a computation. We do number theory. We do cryptography. In terms of codes and doing all that. We do talk about blockchains a little bit even. So by the time we got to the distance learning part, we were talking about computation. So what is a computation? And, we have kind of abstract machines that describe what a computation is. So we have a kind of formal definition of that. And the formal definition, the easiest way to approach it is to use a Turing machine. So, so I had to build a Turing machine, because we didn't really have one. So, and I wanted something interactive. So this is the early version, and it's not hard to understand. So the Turing machine, basically, let me show it. Let me run it so we can see it. This is the early build of the Turing machine. So it's a less complicated machine. And the idea of a Turing machine is that it can describe any computation that even a normal physical computer could, right? So anything you do on a computer could be described by a Turing machine. You just wouldn't want to do it. It would just be so complicated most of the time. So the thing we have to keep in mind is it's an abstract machine, right? And actually it was invented before we really had what we know as digital computers. Alan Turing developed it. And it's the way we describe computation. Now, it's useful for theoretical computer science because we can describe things like how long will an algorithm take to run, right? So we can say, it's going to take an exponential amount of time, or it's going to take this amount of time, or, it gives us some way to base things. So Turing machines are very involved with that as well. It's not the only method that you could use, but it's the easiest one to approach with students. There's also I don't know if you're familiar with the lambda calculus. There's also something called lambda calculus, which is equivalent to a Turing machine.
And I have no idea.
A Lisp-like almost, language that would describe everything that the Turing, they're equivalent. So anyway, let me describe this Turing machine. So basically what you have is you have a tape. So if you see along here, along the bottom, maybe I should use my pen. That might be a good idea. Let me annotate this a little bit. We're getting really fancy now. Yeah, so if you see along the bottom here, there's a tape.
Yeah.
So this is, a tape that you would write on, and the machine has a head, and that head points at a point in the tape, right?
Yeah.
Okay, so we basically have a transition table that tells the machine how is it going to transition from one state to the next, and how is it going, and it can write things on the tape as well. And I made this as an interactive version, so you can see it up here. So in the table, if I'm at state Q0 or Q0, and it's A, okay, it's saying that, okay, stay in state Q0, write an A, so it's just going to overwrite that A and move the tape to the right, right? So hopefully when I go to the next step, if this is still working, yeah, so now it moved over here as well. Okay, so now it's at the second, let me clear my drawing, clear all drawings. Okay, so now it's a Q0A, it's just going to keep moving right, right, according to this state thing. When it gets to Q0B, hopefully it's going to do something different. It will. Okay, so now it's going to change to state Q1. I need my pen back again. I lost my annotation here. Anyways, it's going to change to state Q1, which you can see here. And it's going to write B and it's going to move to the right. Okay, so it's not the most exciting machine, but you should see it changes to Q1, so on, so on. Okay, and usually the asterisks mean, you know, that we're hitting blanks at the end. Okay, so basically you can change this any way that you want. So I wanted the kids, like, you know, to build machines that would count things like, you know, is there an even number of A's on the tape, for example. Okay, we would ask them stuff like that, you know.
Wow.
You know, so you wanted to do all sorts of things. So that's why I wanted to do it interactive. And then I didn't want to just have an answer key, you know, like, and it's kind of the thing that students need to try, right? They want to try their programs and see if it works, right? And so this machine, I should also mention, this machine halts when it gets to an acceptance state or a rejection state. Okay, so if your state ends up being an acceptance state or a rejection state, it's going to stop. Okay, so this was a nice, and then this is something I can only do in Mathematica, you know, like I needed to be able to code this. So this only had 2 states and it only had 2 things that you could write on the tape, right? And so my students kept asking for, of course, you know, these are pretty advanced students, so they wanted more and more and more. Like, why do we only have 2 states, Mr. Tingliff? Or why can I only write 2 things on the tape? Why can, you know? And so like I went through this period of time and I was doing like crazy coding because they kept asking me like to add features, right? Can you add this, Mr. Tingliff? So, and I wasn't actually sure I could do it, actually. And my wife was asking me like, what the hell are you doing? Like, so let me show you unfortunately, the version I ended up with, there seems to be a problem right now with I've made cloud versions as usual with all of these. So this one is the general version that I ended up with, but I think I can get this to work in the cloud. So hopefully if you can see this in the cloud, it would be nice.
Yeah.
Let me make it a little bit larger. So it evolved into this. So again, it's the same Turing machine that you recognize in the last one, right?
Yeah.
But now the students have the option of, they can put in different input states, right? Or they can call them whatever they want, right? And it's actually, if you look at it, it's an interface inside of an interface, which is something I'd never done before. So like, you know, for example, I can come over here. It's a little bit slow because it's the cloud version. Whoops. I should be able to. So let's say I want to put a Q2 state, and the table is now down below. So when I do that, it should also give me the option of, yeah, so now if you notice, there's also the table updated. So now I also can enter the states for Q2 as well, right? So they can create any machine that they really want to, essentially. And they can go in and they can change what states it changes into, whether it moves left or right, what's on the tape. Basically, I gave them everything, right? And there's this, you know, there's even this weird thing that says busy beaver mode. So that's another kind of puzzle for them to try. If I click on busy beaver mode, what you have to do is basically it makes a tape of all blanks, right? And busy beaver mode, they try to write with a certain Turing machine. They try to write as many ones as they can. So this is a famous, you know, computational problem where they, you know, now they can only use 1 and star. Star is a blank, right? And their goal is to write as many ones on the tape as they can. And that gets pretty difficult, actually.
Yeah, it's quite difficult.
Yeah, and it grows exponentially, right? So if you try to, you know, enter more and more states. So like you ask them for 2 states, how many ones do you think you can do on this, right? On this Turing machine. So that was pretty advanced, right? So like, but we kind of went crazy with that, but
Wow.
yeah, so it was fun for me, but
This course is for the senior students, right?
this is for senior students, and they're quite advanced.
Yeah.
These are kids who are, really into computer science. They know a lot in certain areas. They know probably, more than I do. So we kind of learn from each other. But you kind of always have to go back and assume that they don't know anything, even, number bases. I still have to go back to number bases. So I always have to have stuff for students who are like, oh, I've already seen stuff with number bases. We have to do something fancier with them, because they get bored quickly.
Yeah.
So that was kind of advanced. So that's one thing we do. So let me go to show maybe a little bit else. How much time do we have?
It's up to you. Infinitely many.
What's that?
Infinitely many, as much as you want.
Okay. All right. I don't want to bore people either, but I need to get to a place where I can go to the next slide. Okay, let me talk about something different. So, we kind of went on and on with we went into politics, actually. That was another area that we talked about. And we talked about voting systems. So different voting systems. And again, this was something we could do interactively. And I created just a quick Google Doc. At this point, I was burned out from Matematik after the Turing machines. I put the programming away for a while. So here they actually just, we did some voting on what is your favorite soft drink, for example. But they had different systems that we used to vote, right? So one of them might be like, okay, which ones would you approve of, for example? And you can click as many as you want. That was one voting system. Another voting system was to rank them, right? Okay, so rank them from, top to best or whatever. Or we could have a weighted voting system and things like that. And so then, after we compile the results, we kind of went through and said, okay, what do we do with them, right? Which is, and they realized it's a lot more difficult because there's all these paradoxes that come up in voting schemes. Even though it seems so simple, like, I'm just ranking them, right? So, and we talked about, there's something called Arrow's theorem, which talks about, certain voting systems and how no matter what you do, you're always going to end up with a paradox, right? So that was, kind of an interesting topic that we went into. We also talked about, another topic that we talked about was apportionment. I don't think I made a slide for that. So apportionment has to deal with if you have a group of people and they have a representative, somebody's representing a group of people. And let's say your groups are different sizes, how many representatives do they get?
Do you need? Yeah.
Which is also, a major issue, right? You think, okay, this is so simple, right? But, we can't split people into fractional components, right? So, who gets that extra representative or who gets that away, and the US, this always ends up with, this can end up with things in the Supreme Court, because one state complains like, I lost a representative, I picked up a representative. So
I need more representative.
Right, yeah. And so there's a lot of paradoxes with those as well, right? And so, and that's going to happen this year in the States because we have a census. It happens every time you count the population. You have to figure out, how many representatives each state gets. So we're going to have that happen again in the US this year. So it'll be interesting to see how that works out. So actually, the other thing I want to mention is the kids voted for this. They wanted to talk, I'm like, well, what topic do you want to do? Because we were we're not testing or anything. It was the end of the year. They voted to talk about politics a little bit. So the other thing we talked about, we mostly talked about US politics because a lot of these are students going to the US. In statistics class, sometimes we do talk about Turkish politics as well. And sometimes there's some interesting political maps that you can, look at. But that didn't happen during the distance learning period. But, we focus mostly on U.S. politics in this one. So
Okay.
I apologize for the U.S. part, but in statistics, I usually do both. We talk about because it's interesting. So another issue in the U.S., after you get the number of or you count the population, is we have voting districts. So each state has a voting districts, and you have to draw the lines for those voting districts. So, and when you do that, that's a major issue in the United States because it's highly, politicized. And so they'll draw, very strange looking maps, to try to group a bunch of Republicans or a bunch of Democrats together, or split, a group and things like that. So it's a major issue, and they have mathematicians who are trying to help, define what is something that we call it gerrymandering. In the U.S., it's called gerrymandering.
Oh.
After I forgot his last name was Jerry. It was a politician from Massachusetts, and he had originally, I think it was in 1812, he drew a political map. And people said, wow, that looks like a salamander, which is kind of a lizard-like looking like creature, right? And so they took his name and they called it a gerrymander. And so that's how we got the name gerrymandering.
I always wonder about how do they decide about these voting districts, because in Istanbul we do have like 3 districts as far as I know.
Yeah.
And I wonder about how do they decide it.
Yeah.
In US, there's a science behind that. Wow. So
there is and there isn't.
There isn't? Oh.
I mean, it's left up to each state. So the thing is, each state does it differently. So we don't have like national control over it. And so some states it may be okay, and other states, they think that it's been broken across, racial lines and things like this, and it causes major issues because it might not matter how you vote, right? The map is actually more important, right?
Yeah, exactly.
If they split up the voters and things like that. So, one example they give is Massachusetts, and Massachusetts is mostly Democratic, but it has Republicans. And because of the fact that the Republicans are so spread out over all the states, they never get any Republican representatives, right? Because of the distribution, like they're distributed evenly throughout the state, right? And they said in Massachusetts' case, mathematicians have said, it doesn't matter how you draw the map, you're never going to get any Republican representation, right? Because there's just no way you can draw the map if, everybody's spread out and nobody's in groups, There's so many issues. There's so many issues. And then like people who are like-minded tend to move together, right?
Yeah,
and that also causes a problem without the gerrymandering. So anyway, so one thing that we did actually, and this is a game that we played. So there's a game that's called the redistricting game. So hopefully, let me show that quickly. Okay, so you should be able to see my screen now. Again, I want them to actually try it, right? So this game was actually great. And I thought originally that, so there's all these missions that you go through, right? So you can try the basic. I'll just try the basic of the first one just to show you what it looks like. Oh, it says my Flash player is blocked.
Oh, no.
No, that's not good. All right. It wasn't before, but anyways, so you actually go through the game and you have to actually draw the districts, right? So you go through and you draw the districts, and then it has to go through an approval process, but it's actually really hard, to actually try it and to meet all these requirements, right? So it goes through and you have to meet all these requirements. And when I tried it, before I tried it with the students, I thought, wow, again, it's kind of like what I told you with the Rubik's Cube. I thought, wow, I'm not very smart, right? And then, some of my brightest students, some of them going to MIT and stuff, right? They said, that was pretty hard, Mr. Dinghoff. I was like, oh, phew. It's not just me, like, because it gets harder and harder. So, but anyways, it was really an interesting experience, and it was interactive, right? So it was something that we could do interactively. Okay, let's see. Do I have anything else? Okay, so just maybe a couple more things. Maybe I'll take maybe 10 more minutes, and
all right,
we'll wrap up. So, another topic that actually is kind of close to my heart is to combine biology and math, right? So I've even taught some RC Summer Academy courses on that. Because my wife is a biology teacher and my biology is pretty bad, so I need to work with her. So, you know, a lot of times we've taught joint interdisciplinary classes. And ironically, you know, one of the things that we taught in the fall was about epidemiology and the spread of disease, right? Right before Corona, you know.
Yeah.
We didn't realize that Corona was going to happen, but we talked about this with our students and what are some of the math and what's some of the mathematical models and you know, what is an R naught value. And it's a very rich subject in terms of there's so much that you can do in terms of interdisciplinary math with math and biology. And I actually took a course. We did a course with my wife. She found this course at Rutgers University in the United States. And they wanted math and biology teacher pairs to sign up. So you had to sign up as a pair. And we were the only married couple, actually. So I was married to the biology side. And we joined this course and it was 2 weeks long and I had to take biology for a week. And she had to take math and I don't remember much biology. So it was like mostly DNA stuff, you know, and my wife doesn't like math very much.
For me, biology, like when I was a high school student, biology is the worst lesson that I succeeded. Like I got, I don't know, I got 2 out of 5. I think, I'm not sure. But
Right.
like, it's so hard for me to memorize all the stuff in there.
Yeah, it's difficult. Like, and I had a hard time. It was like biology was hard. But the point of this was that they wanted to have teachers because now they're, you know, for the biotech industry and stuff like that, they're like, we need people who have both the biology and the math, you know, and can do it in an interdisciplinary way. And we need to start in high school. That was, you know, basically their idea. And so, you know, we brought stuff back to we did stuff with DNA, basically, like DNA sequencing and stuff like that. We brought it back to the high school just to introduce stuff. And I do stuff in the discrete, you know, with some of that as well. And it's an eye opener, I think, for some of the students. So there's 2 ways actually that I do it in the discrete class. In the first semester in the discrete class, we did it with DNA sequences and how do you build a tree? Like, you know, for example, if you have a virus, how is one strain of the virus, you know, connected to the other, and how do we think it's mutated, and what's the mathematical model for doing that? And we also talked about, I mentioned the epidemiology, the spread of the disease. In the distance learning part, we actually talked about game theory. So we combined game theory and evolution. And so that was, and again, I'm working with CoMap. So let me open that. I think it should open, hopefully. Okay, yeah.
Biomass, all right.
Yeah, so they have lots of modules. And so one of them, this is actually was formed from the group that we worked with when we went to this workshop. And so basically what I had the students do is actually go through and play some of these games, right? Like, so similar to rock, paper, scissors, you can kind of see here that it's actually, I think its origin is it's an Italian game called Two Finger Moira. And they, you know, like, so you have to do, like you show 2 fingers, I show 1 finger, and you have to decide, it has to happen at the same time, like rock, paper, scissors, but a simpler version. And, you know, one can, and what you basically have is you have some game theory table that will tell you like, what are the payoffs, for example. If this, you know, one person shows 1 finger, the other person shows 2 fingers, what's the payoff going to be, right? But then it gets more and more complicated, right? So like, what if we go through generations and somebody, you know, an organism only shows 1 finger, you know, it has a certain profile, and another organism has another profile. It shows, you know, so it gets more and more complicated, and we can see what happens like after generations of generations. So it builds kind of like a mathematical model. But again, it was something that we could do interactive, right? Like, so they could get again in a Zoom classroom and, you know, or a breakout room and, you know, try this and then try it on their own, and something that I could do, you know, synchronous. So that was also another, and if you want to check that out, you can go to CoMap. You know, CoMap has lots of great modeling activities.
Oh.
So that was just another idea. I'm probably throwing a lot at you at this point. So. The last one I wanted to talk about, just because it was just a fun activity. It didn't happen during the distance learning part, but this is about logic, and this also came from the discrete class. We talked a lot about logic and ors and all these kind of things, but I wanted to relate it back to something that was, we could really do something with the logic. Actually, it was one of my students' ideas, and it was his idea several years ago, is to use a 7-segment display. So what a 7-segment display is, I'll just show that quickly, maybe from this website. So this, it's basically just one of these LED number things, right? That you've seen we've all seen them somewhere. But basically it uses, a logic, basically like Boolean algebra, right? To come up with which segments do I light up, right? Okay, so, and it's actually quite complicated. We were trying to think about like, okay, so what kind of and/or circuits would we need to, if we inputted it, like if we tell it's a 0, right? You have to line up, you have to light up the A segment, the B segment, the C segment, the D segment. But when it inputs a 1, you have to light up these other segments and turn the other ones off, right? So based on the input, can you light up these different numbers, right? So I actually wanted to try that with the students. And so luckily we had somebody this year who visited us from Texas Instruments. And I can show you, I don't have the whole setup here right now, but basically what this is TI Innovator Hub. I don't know if you've ever seen one of these.
Yeah, I've seen.
And I hooked it up to a breadboard. And on the breadboard, if I can hold it really close, you should be able to see there's a 7-segment display, right? So I had the kids break up into groups, actually, and each student was responsible for one of these segments that you see here on the A, B, C, D, E, F, G, right? So each student was responsible, a group of students was responsible for the logic of that part, right? And then they had to enter the logic into their TI, and they sent their logic statement to me, and then we tested it out. We went through like each number to see if each group was correctly lighting the segment as we went through.
Okay, so do they select their numbers randomly, or are you giving them purposely like
no, we have to get through all of it. Yeah, so basically there's a lot of actually logic involved, and we use something actually called a Carnot map. You probably, or a K map, you're probably not familiar with that. It's just a way of reducing a Boolean algebra statement. So you might have a lot of ands and ors in this, right? And if you try to do that kind of just using algebra, it's a pain, right? Like you just get lost in all of it. So there's some shortcuts that you can use to doing that. So we use what we call a K map. They learn a K map. So I'm not going to go into what a K map is, but that was to try to come up with the simplest algebraic expression to light up their segments, essentially. So there was a group that was working on the A segment, for example. There was a group that was working on the B segment, right? Okay. And so when they each gave me the logic for that, I kind of just input the number. Okay, so for a 0, right? If it's number 0, is it lighting up the right segments, right?
Yeah.
So I would go through, and this is what I would expect to see if I see 0, but if a group wasn't lighting up the top segment or something, oh, group A has done something wrong, right? And some of it was kind of dramatic. I would go through like 8 numbers, it would be correct, and we would get to number 9, and they'd be like, oh my gosh, group A blew it, it didn't light up the top, right? Kind of thing. But it was kind of a fun activity just to kind of wrap up logic, which can be kind of dry, it's kind of sometimes a dry subject. And they could see like, okay, this is some way that, the logic of the circuit should be able to work out, what this is. Now, of course, it's on some integrated circuit normally and like extremely small, right? Not a setup like this. And I did the wiring for this, so I didn't want them to fuss with that. I wanted them to fuss with just the logic part. So
Yeah, and it's time consuming to to prepare all this,
It's
connecting the hub to the TI
long,
calculator.
and I'm getting old. I'm like trying to find like where the little pins go and stuff like that. But it was, I think a nice way to wrap up the logic unit. So, which I think, it could possibly fit into distance learning as well. Like we could have a group off working on the logic of this, another group working on this. We actually did this one in the classroom, so this wasn't a distance learning one. So, all right. So I think that's about it for today.
I think it's more than enough. Like,
Yeah,
I'm so
I can go on and on. Like that's my problem. So.
Like, wow, it's amazing, like learning these activities and these tools. Actually,
Yeah.
like the stuff about Matematica. I'm really impressed, and maybe like I can start tomorrow learning Matematica. But as you said before, like it's not an easy thing to learn, right?
Yeah. I think right now, I'm thinking my recommendation would probably just be go with Desmos.
Oh, okay. All right.
In general, like it depends on how advanced that you're working with stuff. Like I was telling you earlier, I don't know if we talked about it in here, but the discrete stuff, some of it gets pretty advanced, and it's not something Desmos could do. Like I couldn't nicely create an activity. Like I couldn't build that Turing machine, right?
Yeah.
On Desmos, right? But I think for the majority of activities that you would want to do, at least for graphing and things like that, you could do on Desmos, and it might be a better use of your time to look at the computation layer. I'm thinking, this is what I'm not an expert, so that might be easier than working in Mathematica.
Yeah. Yeah. It can but like teaching discrete maths. Yeah, the Mathematica is the only choice. But no,
Yeah.
it is. I think if you're teaching AP, yeah, you need
Mhm.
to use Mathematica. But like I'm teaching IB, in IB, I don't believe like there's such a thing, such a lesson called discrete math.
I think
So
there used to be a higher level.
yeah, like they changed the curriculum. Now they combine the high level, like, and the further math and the high math together.
Okay. Yeah, but it wasn't as, we're a little bit unusual in the fact that we run a year-long discrete math course. Like,
Yeah.
usually it's a semester course in a high school. So we get it, pretty far in depth. But even the IB, I think it was like 1/3 of a year or something like that. It wasn't like
Yeah, it's something like
that
that.
big a discrete course. So yeah, but I think, Desmos seems like a good option. Things like Desmos GeoGebra, are probably the best options for the majority of teachers to use, right?
They're so popular. They're
Yeah.
so popular.
But there's a reason they're popular too, right?
Yeah, of course. And the thing is, like most of the time, for instance, I like as an example, I can give myself like I use the activities that the teachers are already prepared for us. But the thing is, creating a new one is such a big thing. But
Yeah.
and like while preparing such an activity like this, you can learn a lot. By the way,
Yeah.
maybe I can work on that. Yeah, it's a good idea.
Yeah, usually a lot of my activities, especially the more complicated ones, normally it kind of gets built over years of teaching the same course over and over again. And I just make modifications and build things. The Turing machine was a little bit unusual, and I just built it all at once. But also I was at home. Like normally I wouldn't have time to do that, right? Like, so
Yeah.
the other thing is the distance learning, you have all these other things you have to deal with, assessment.
I was about to ask this question. How did you find time about
Yeah,
creating those kinds of
normally there wouldn't be time to do this, and it probably wouldn't have been done, right? Like in a normal classroom setting, because there's just too many other things to deal with. I have a daughter as well, so but it just happened. But the normal flow of things for me is like it kind of slowly happens, over the years, kind of, right? And I guess this 7-segment display thing is kind of an example of that, because it was actually a suggestion from a student. He's like, wow, this is kind of like the 7-segment displays that we did in electronics. And then when I went in and I looked at it, I said, yeah, actually, we could do something with this. But then, a whole year went by and I didn't do anything. And then slowly I started to look at it. I started to add things. I started to build it. It took several years actually before this could actually really become an activity in a classroom.
Yeah.
So yeah, and I think it's good to use other teacher stuff first, then try to develop your own. So
Okay, so I must say, like, thank you for this. No, firstly for this talk. I learned a lot from you. I think our audience learned a lot from you as well.
Yeah, thanks for inviting me. I also looked at some of the other videos that other teachers have done, and thanks for sharing those. You know, I saw some good stuff like, you know, talking about kangaroo mathematics contests. You know, my daughter does those as well. And I think talking about I saw Martin Gardner was also mentioned, and
Yeah,
I think the middle school one, I think it was in the,
yeah.
yeah, but I mean, he's also a good source for kind of, you know, good questions to try. So, you know, thanks for the other teachers as well who've shared stuff, and thanks for setting this up. I think it's a good opportunity for teachers. So, you know, thanks for all the effort you put in, Watch.
We are open to every math teacher to share their ideas. So we invite all of them, all of around the world, and especially in Turkey.
Yeah.
Like, if they are ready to share their ideas and their activities, we're open to them.
And thanks for making me famous. My students are not famous now. I said, I don't know about if I'm famous or not.
I think tomorrow you'll understand if you're famous or not.
It's all because of Watch. So.
Yeah.
Anyway, okay, thank you very much.
Thank you for your attendance.
Okay, bye. See you.
See you.